Hello everyone and welcome to the lecture on AWS Code Artifact. So this lecture will contain all these topics. What is AWS Code Artifact? How Code Artifact works, and then followed by all the concepts which are asset, domain, repository, package, package group, package namespace, package version revision, upstream repository, configure and use npm with Code Artifact, configure and use pip with Code Artifact, and Code Artifact integration with code build. So what is Code Artifact? Code Artifact is a fully managed service that helps organizations store and share software packages for application development. Code Artifact ensures the security of your packages and offers high scalability to support your growing development needs. Code Artifact seamlessly integrates with widely used tools such as NuGet, Maven, Gradle, npm, Yarn, pip, and Twine. By using Code Artifact, you can reduce the burden of managing your own artifact storage system and focus on your application development. Code Artifact allows you to create connections between your private repository and external public repository like npm.js or Maven Central. When a package manager requests a package, Code Artifact automatically fetches and stores it from the connected public repository, ensuring availability for builds and development. You can publish proprietary software components as private packages in Code Artifact, enabling easy sharing between multiple applications and development teams within your organization. So how Code Artifact works? Code Artifact repositories can contain packages of any supported type, making them versatile for different development needs. Each Code Artifact repository belongs to a single domain. It is recommended to use one production domain for your organization with repositories for different development teams. To add packages to a repository, configure a package manager, for example npm or Maven, to use the repository endpoint URL, then use the package manager to publish packages. Code Artifact allows importing open source packages into a repository by configuring an external connection to a public repository, for example npm.js, NuGet Gallery, Maven Central, PyPy. Within the same domain, you can make packages from one repository available to another by configuring one repository as an upstream of the other. This allows downstream repositories to access packages from the upstream repository and any connected public repositories. Users must authenticate with Code Artifact using an authorization token created with AWS credentials to publish or consume package versions. Code Artifact repositories do not allow packages to be made publicly available, ensuring secure access control within the organization. So just to summarize, Code Artifact, you can just think of it as it's a repository to have all the packages. So generally when we do some kind of open source development, we use npm.js or PyPy to fetch the packages, and sometime open source developer push the packages. But usually in bigger enterprises, they have their own artifact repository like Code Artifact repository. So you will release multiple versions of a software or an application, and each version will finally let's say produce a jar file or something in the case of Maven. So all jar file will be depending on the version and the environment, it will be labeled, right? But there must be a central way to actually fetch and publish and consume this. So as a developer, you may be required to consume some private libraries or packages. So in those cases, Code Artifact is a must, or some kind of tool which is similar to Code Artifact is a must, because you want to make sure all your development is secure and you pushed to a secure location. And usually these jar files are not like source code where you can put in GitHub or code commit. It's basically very large packages, 10 megabyte, 100 MB or something. They are basically library packages. So there is a central way to actually consume, publish, fetch and use these kind of packages or the Code Artifact. Okay, let's go through all the concept one by one. First is asset. An asset is an individual file stored in Code Artifact that is associated with a package version such as npm or .tgz file or Maven POM and jar files. So these are the list of assets. So in case of POM Maven, we usually use a .pom file, which is used in the case of Maven. Then you have a domain. Repositories are tagged into a higher level entity known as domain. All package assets and metadata are stored in the domain, but they are consumed through repositories. A given package asset, such as a Maven jar file, is stored once per domain, no matter how many repository it is present in. All of the assets and metadata in a domain are encrypted with the same AWS KMS key stored in AWS Key Management Service. Each repository is a member of a single domain and cannot be moved to a different domain. Using a domain, you can apply an organizational policy across multiple repositories, and with this approach, you can determine which accounts can access repositories in the domain and which public repository can be used as the source of packages. Although an organization can have multiple domains, it is recommended to use a single production domain that contains all the published artifacts. That way, teams can find and share packages across your organization. Next is repository. A code artifact repository contains a set of package versions, each of which maps to a set of assets. Repositories are a polyglot. A single repository can contain packages of any supported type. It means different languages. Each repository exposes endpoints for fetching and publishing packages using tools like NuGet CLI, NPM CLI, Maven CLI, and pip. You can create up to 1000 repositories per domain. So domain is the highest level entity, and under that comes the repository. So domain is something like an endpoint, like a URL, and under that you can have a named repository. Then you have a package. A package is a bundle of software and the metadata that is required to resolve dependencies and install the software. In CodeArtifact, a package consists of a package name and optional namespace such as add types in add types/node in case of Node.js, a set of package versions, and package level metadata such as npm tags. AWS CodeArtifact supports currently all these types of package formats, which are npm, PyPy, Maven, NuGet, Swift, Ruby, and generic package formats. Next, we have package group. A package group can be used to apply configuration to multiple packages that match a defined pattern using a package format, a package namespace, and a package name. You can use package groups to more conveniently configure package origin controls for multiple packages. Package origin controls are used to block or allow ingestion or publishing of new package versions, which protects users from malicious actions known as dependency substitution attacks. Next is package namespace. Some package formats support hierarchical package names to organize packages into logical groups and help avoid name collisions. For example, npm supports scopes. The npm package add types/node has a scope of add types and a name of a node. There are many other package names in add types/scope. So in CodeArtifact, the scope types is referred to as the package namespace and the name node is referred to as the package name. Similarly, for Maven packages, the package namespace correspond to the Maven group ID. The Maven package, for example, org.apache.logging.log4j.log4j has a group ID, package namespace of org. So the first namespace, which is the what we call package, and then the class, which is org.apache.logging.log4j, which is the actual namespace, and the artifact name, which is final thing.log4j. So for generic packages, a namespace is required, and some package formats such as PyPy don't support hierarchical names with this concept. So it's about Python. So Python does not have the same support. So do not support hierarchical namespace with concepts similar to npm scope or Maven group ID. And without a way to group package names, it can be more difficult to avoid name collisions. So this is in certain cases. So this is, for example, in case of Java. We know in Java we have packages and classes. So the packages are the top level entity, and inside that we have a class or something. So that is the lower level entity. So this has a group ID, and this is the package namespace. So this is the one example. And in the case of npm or node, there is a add type/node concept. So this is how you avoid any kind of namespace collision when you import any library or some code. Okay, next is package version. A package version identifies the specific version of a package, such as add type/node 12.6.9. So in case of a node, we have the version also. The package number, format, and semantics vary for different package formats. For example, npm package versions must conform to the semantic version specification. In CodeArtifact, a package version consists of the version identifier, package version level metadata, and a set of assets. Next we have package version revision. A package version revision is a string that identifies a specific set of assets and metadata for a package version. Each time a package version is updated, a new package version revision is created. For example, you might publish a source distribution archive sdist for a Python package version and later add a Python wheel that contains compiled code to the same version. So when you publish the wheel, a new package version revision is created. This is a specific example in case of a Python. Okay, last concept is upstream repository. So one repository is upstream of another when the package version in it can be accessed from the repository endpoint of the downstream repository. This approach effectively merges the contents of the two repositories from the point of view of a client. Using Artifact, you can create an upstream relationship between two repositories. So basically, you have a repository 1 and let's say repository 2. So repository 1 is an upstream of repository 2. So this is like a parent and this is like a child. So when you pull some code from let's say repository 2, you can have some inheritance policy that it can, if it does not find here, it can go up and you can have some kind of a relationship set between repository 1, whether there is a one directional sync or two directional sync or something like that. So you can set up like that also. So this is easier to actually basically manage and to avoid any kind of duplication effort. Okay, so now just quick examples. Let's say how to use CodeArtifact with npm. So by default, if you don't use any repository, you will be using npm this registry.npm.js. So when you say npm install Lodash or something, it will fetch. If you don't have any configuration on your computer, it will fetch from the central repository. So this is hard coded directly in the code, so we have to find. So that's why we don't have to do any configuration. But let's say you are using CodeArtifact. What you have to do first is to log in using AWS CLI CodeArtifact service login and the tool you want to use, and you specify the domain which you have created and the AWS account ID. This is a 12-digit ID and the repository name that you have created. So let's say it's my repository. So you just run one command. It will in your hidden folder or the hidden file .npmrc, it will set up this particular npm registry. Right, and then if you do npm install Lodash, it will go and look here first, and if you want to publish some private packages or node modules, you will say npm publish and it will publish over here. So this is for private, this is for enterprises and all. And you just, if you want to verify, you can just do npm -ping. It will see it will take, this is whatever is you have configured, it will check whether it can connect or not. And if you want to use the you want to fail over to the default npm, you can just npm config set to the actual original one. We don't do this because it's already there, but this is even if you start using CodeArtifact, you have to do this step. And same for this another example, Python. So same concept, AWS CodeArtifact. It will configure the global pip config file, and then if you do pip install request, it will fetch from here. Or if you do pip install -i, if you want to fail back to the original, you got to do like this. And lastly, CodeArtifact integration with code build. So this is what we have seen is from a developer point of view, what command to run. But actually, for 100% automation, what you will do in your code build or Jenkins or whichever continuous integration tool, you have something like you have build environment, runtime and all. But when you have a build project phase where you compile and all, and finally you make a let's say jar file or something, then you have two options. To first, if there is some dependency, you can retrieve the package from the CodeArtifact repository. So this is the CodeArtifact, and code build will fetch it and it will build some code. And after that, if you want to publish, you just have to run the publish command, and it will store the whatever artifact or the jar file or library back to the repository. So you may pull from some package or namespace and then finally push to some other project. So this is how it looks like. So this is for npm case. So all we do is in the code build service, we just we just add these two commands in the YAML file. We say pip3 install AWS CLI to install the if it's not there, or upgrade AWS code artifact. So just run this, and then after that, during the build phase, npm install will pull in all the node modules, private node modules. Similarly, for the Python case, we do the, again, just login step, and we just say pip install request. It will, if you have private Python packages, it will pull in from the code artifact. And that's all. Thanks for watching.